Okay, this recording is going to go over the flip chart you should have completed by class tomorrow. On the first page, basically 4-2, using intercepts, remember what we talked about is when you have something in standard form, like for instance 3x plus 2y equals 12, you're simply going to put a 0 in for x and solve for y. And then you're going to do the same thing, 3x plus 2y equals 12, and you're going to plug in a 0 for y. And the reason you want to do that is to find where it crosses the x and y axis. So, for instance, if I put in a 0 here, if I plug in a 0 for x, all right, that's going to give me this coordinate point. Well, that's gone, so I'm left with 2y equals 12. Divide by 2, and y is 6. So we can say that when x, let me write that better. So when x is 0, y is going to be 6. So you can graph that point. Now, what if I happen to plug in a 0 for the y? Well, 2 times 0 is 0. You bring down your 3x equals 12, and the coordinate point is going to look like this. You're going to have a 0 for the y. So when you divide by 3, x equals 4, so you can say when y is 0, x is 4, and that's how I graphed this graph right here. Now, if you have a graph that or an equation that's non-standard, and what I mean by that is, like this graph, this equation here is in the y equals mx plus b format. That's in the y-intercept form. You can still do the same thing. I plugged in a 0 for x first. That canceled this out and left me with y equals -1. And that's what gave me this coordinate point right there of 0, -1, which I graphed at that point. Then I plugged in 0 for y right here, but then I had to solve for x. And I came up with 3/2. So at 1, 1.5, 0, that's where I plotted that point, and I simply just connected the two lines, the two dots. Now, on 4-7, point slope form, just like with slope intercept, where you need a slope and an intercept, here you simply need just a point and a slope. And I want you to look. You have the formula of y minus y equals your slope times x minus x. Well, where does that come from? That actually comes from your slope formula, m equals y minus y over x minus x. These three components are used in this formula right here. If I get rid of this fraction by multiplying both sides by x minus x, what I end up getting is that's gone, that's gone. I'm left with y minus y is equal to, let me flip the order, m times x minus x. And because it's an equation, I can rewrite it like this. Y minus y equals m times x minus x. And you notice it's the exact same thing as our point slope formula. Now, what are you going to do with that point slope formula? Well, as long as you have a point and a slope, you can graph anything. And in fact, not only can you graph, you can change it to a slope intercept problem. All right, so let's go ahead and bring this back up again. Let me make it a little bit bigger. All right, so for instance, you write out the formula y minus, and notice I put a box. That's going to be the y point of your coordinate point, equals another box. This is where your slope goes. And then, of course, in parentheses, x minus another box. And that's where the x variable. So if you had a coordinate point, let's say 3, 7. Since 3 is my x, that goes right there. And since 7 is my y, that would go in that box. The only thing we would need now is a slope. Well, let's say our slope is 1/2. I would simply put 1/2 in the box. And this is point slope form. And we'll show you later what you can do with that point slope form by using the distribution method. Okay? Let's go ahead and take a look. I'm going to erase this part right here. Let's take a look up above at the example I gave y'all. I gave you the slope of 1/3. Okay. I gave you the slope of 1/3 right here, and a point of 3/4. Notice I plugged in my slope right here. 3 is my x, 4 is my y. So 4 goes there, 3 goes there. And I simply have a point slope form. Same thing down here. You can see I put the slope as -6. My y value was 2. My x value was 1. And it gave me this equation. Okay? Now, let's talk about parallel and perpendicular lines. Parallel lines, if you draw them, are going to have the same slope. So they're two straight lines that never cross. They have the same slope. For instance, if I were to graph these two, they would never cross because they both have a slope of 2/3. On a graph, one would start at +1 and would go up to right 3. The second one would start down here at -7 and would go up to right 3. And so, therefore, they would have the same slope. They would never cross. Conversely, if you look at perpendicular lines cross and make a right angle of 90 degrees. Now, we don't really measure that on a graph, but you should be able to visually see that. The slopes are negative reciprocals. So if I have an equation of y equals 1/3 x minus 1, if I wanted it to be perpendicular, I simply flip the slope and change the sign. For instance, if I were to give you a slope of, let's see, 2/5, the perpendicular, this is the sign for perpendicular, the perpendicular slope would be negative and the reciprocal, 5/2. What if I gave you the slope of 3? Well, the reciprocal of 3 is 3/1. The reciprocal is 1/3. And you would change it to negative in order for it to be a perpendicular slope. All right? Now, let's kind of move some things around. These are called transformations. All right? Transformation. Okay? Basically what that means is that we're going to be moving graphs around. And there's two things that I want to look at. Okay? I want to look at how changing the y-intercept and the slope are both going to, how changing the y-intercept and the slope are going to affect the graph. Now, you have something called a parent function, which is normally called f of x equals x. Or, since you know another name for f of x is y, you can say y is equal to x. And it looks like this graph here, where it has a slope of 1, 1/1, 1/1, all the way up and down. And it's a positive slope. So the first thing we're going to look at is some translations up and down comparing y equals x. Now, I want you to notice I put a little 0 here because if you have the equation y equals x, you have your slope of 1, but where's the b? Where's the y-intercept? Well, because it's not there, we put a 0 in its place. That tells me when you graph it, it's going to start at 0, 0. And then it's going to go up 1, right 1, and therefore you can make a little graph that way. So we're going to compare all our graphs to this equation right now. Okay, let me get rid of this. Okay, so now, if you notice, I put a bunch of equations here. I put x minus 4, y equals x plus 2, x plus 5. Notice they all have the same slope, but all the y-intercepts are different. So this one started at -4. That's why I put y equals x minus 4. This one started at x plus 2. So that's this line right here. X plus 5 started right here. So that's why I created x plus 5 right there. Notice they're all parallel because they have the same slope of 1. All right? Now, what happens when you change the slope? Well, again, it's called a rotation, and the slopes all change. Now, to illustrate this point, notice I kept all the y-intercepts at 0, so that this point right there. And the only thing I did was change the slope. So if you notice, the slope on the parent function is 1. So this is the parent function. So 1 over 1 created that positive slope. Now I changed the slope to a 3, and so you'd go up 3 and to the right 1, and then down 3 and to the left 1, and that created this line right here. It's still a positive slope, but it's more steep. So notice going from 1 to 3, increasing the slope, made the graph steeper. And then finally, if you look at this next one, you'll notice that it's a negative 1/2. Well, my slope is now down 1 to the right 2, down 1 to the right 2, or conversely up 1 to the left 2, and it helped me create this line. So they all have the same y-intercept right here in the middle, but the slopes change. So that's what causes them to rotate. And then finally, what if you put all of those together? What if you do a translation with what if you slide it up and down and rotate it? Well, let's look. Right here, I'm starting with the equation y equals 2x plus 1, and I graphed it. There's my plus 1, and I went up 2 to the right 1, and I went down 2 to the left 1, and I created this line. Okay? Then I changed the slope from a 2 to 2/3. I kept the y-intercepts the same. If you notice, my y-intercept is 1, my y-intercept is 1, and that's what I put right there. But my slope, I went up 2 to the right 3. So I changed it from 2 to 2/3. So I went up 2 to the right 3 and then down 2 to left 3, which lowered my slope. So it went from up here, it decreased. Now I'm going to use the same slope of 2/3, but I'm going to change the y-intercept to a -3 now. Well, 2/3 is going to give me, so if I go down here to -3, notice I went a difference of 1, 2, 3, 4. I went down 4 units to get to my new y-intercept. I kept the same slope of 2/3, so I went up 2 to the right 3, which gave me this same slope. So the slope stayed the same, but the graph shifted down 4 units. So what I ended up doing, I technically started, let me show you, I technically started with y equals 2x plus 1. I then shifted to y equals 2/3 x plus 1. Notice I only changed the slopes, and then finally ended up at y equals 2/3 x minus 3. So in reality, I basically rotated because the slopes changed, and then when I went from 1 to 3, I translated. And those are the transformations that occurred. I know that doesn't look like translated, but let me rewrite that. Okay, it translated. And that's what I need you to have. I need you to have all these notes on your flip chart when you come into class tomorrow so we can practice. Have a good evening.